Assalamu alaikum students, this is Farwa Batul, your O-level computer science instructor, and welcome to another video of chapter number 10, Boolean logic. In this video, we are going to start topic number 3, that is logic circuits, logic expressions, truth tables, and problem statements. If you don't understand any of these terms, please watch the video of introduction of Boolean logic, because in that video I have showed you everything, the logic circuit, logic expression, and truth tables. Okay, so quickly moving towards the practical example of this, that how we can solve the different problems, how we can make the logic expressions out of logic circuits, how we can use the truth tables and all. So let me just share with you problem number 1 of your book. Okay, so here we go. This is problem number 1 that says that produce a truth table. Look over here. Truth table we need to produce for the following logic circuit. The logic circuit is given below. Note the use of black circles at the junctions between wires. The black circles, okay, fine. Let me explain you in my words. Below, I have a logic circuit. And remember that a logic circuit is the one that is made up of different logic gates. In the previous video, we have seen the 6 standard logic gates that we use in order to make logic circuits. So let me explain you this logic circuit that is given below. Here I have 3 inputs. Look at this. A, B, C. These are the 3 initial inputs that are going into the logic gates. Now, remember that an input can have only 2 values. It's a binary input, so A can have a value 0 or 1. Similarly, B can have a value 0 and 1. And C is also considered as input, so it can have a value 0 and 1. So it depends upon our combinations, input combinations, that what would be the values of this A, B, C. Okay, next to this is your logic gate. Look at here. This is your logic gate number 1. This is AND gate, A and D AND gate. And AND gate is the gate that takes 2 inputs and gives 1 output. So look at here. It is taking A and B as inputs, and it is giving us output which is named as P. P is the output of this AND gate. And if I talk about the function of AND gate, so it is simply doing the multiplication of the bits. Okay. If I see gate number 2 that is down here, this gate is known as a NOR gate. A NOR gate is actually the reverse of OR gate. We have seen in the previous video the functions of all of these gates. So that is you have to learn. Now, NOR gate is the gate that takes 2 inputs. So we can easily see that one is B that is coming inside NOR gate and the other input is C. So B and C are the inputs of NOR gate, and it is giving us output value which is named as Q. You are seeing the output value Q. Okay, once you take the outputs of AND and NOR gate, these outputs are going to become the inputs of another logic gate. That is the OR gate, OR gate. OR gate is nothing but the addition of bits that it is taking as input. So, P and Q are the values of PQ are the inputs of OR gate, and the output of OR gate is named as R. So R will be the output of OR gate. Next to it we have a XOR gate. It's the fourth logic gate over here. This is XOR gate. XOR gate also takes 2 input values and gives us 1 output. So if you see the input lines, one input line is coming from C. So C is one input for the XOR gate and the other is R, that is going in the XOR gate. So R and C will be the input of XOR gate and the output is your final output of the logic circuit, which is named as X. Now, before solving the problem, you must know the functions of each of these gates so you can fill the truth table easily. And if you don't know the functions, please watch the previous video quickly. Now, let me show you the truth table and then we will start filling it. Okay, so here we go. This is your logic circuit and this is the truth table that we need to fill. So look at the truth table first. In the truth table, we have A, B, C. These are the initial inputs. This A, this B, and this C. These are the input values. And remember that if you have 3 inputs, then there will be 8 combinations. How we calculate that? 2 raised to the power n, where n is the number of inputs. So when you put 3 over here, 2 twos are 4, 4 twos are 8. So it will become 8 input combinations. What is the meaning of 8 input combinations? Let me tell you. Remember that the values of A, B, C will be 0 or 1. So let's start putting the values of C first. It will be 0, 1, 0, 1, 0, 1, 0, 1. In the column of C, we will do like 0, 1, 0, 1, 0, 1, 0, 1. This is how we can make the input combinations. In the last input value, which is C, we will put like alternative values 0 1 0 1 0 1 0 1. In column B, we will be putting 2 zeros and then 2 ones, then 2 zeros, then 2 ones. Okay, and next in A, the third input value, we will put like 40. It is in the power of 2. It is 2 raised to the power 0 equals to 1. Then 2 raised to the power 1 equals to 2. So it means 2 0 2 1 2 0 2 1. And the third column will be 2 raised to the power 2, which is 4. So it is 4 zeros and 4 ones. So remember, if you have 4 input values like A, B, C, D. So in D, column D, you will be putting alternate values like 0, 1, 0, 1, 0, 1. Then in C, you will put 2, 0, then 2, 1, then 2, 0, then 2, 1. In column B, you will put 4 zeros and 4 ones. And finally, in column A, it is the case when you have 4 input values. So you can put 2 raised to the power 3, that is 8. It means 8 zeros and then 8 ones will be down. So this is just an additional information for you. But in this example, since we have only 3 inputs, so what we will do, we will make a combination like this. The C will be 0 1 0 1 0 1, B will be 2 0 2 1 2 0 2 1, and A will be 4 zeros and 4 ones. So in this way we can make 8 different input combinations. So every input combination will be different from the above one. This is not similar to each other. This one not similar to up. So in order to make 8 different input combinations, we use this technique. Okay, now quickly, if you understand this, quickly moving towards P and Q. I have already mentioned that P and Q, this and this, are basically the outputs of and NOR gate. So if I write over here with P, if I write that it is A and B, so it will not be wrong. So it means P is A and B. And for Q, if I write that this is basically the function NOR. NOR is done between B and C. So if I can write it is B NOR C, then it will not be wrong. Now for R, look at R. R is also an intermediate input. Intermediate values are those values that are between the circuits that you see after every logic gate, that is in between your inputs and the final output. So these are the intermediate values. Now R is the output of your OR gate and it is taking P and Q as an input. So if I write that R is basically the result of P or Q, then it will not be wrong. It is completely understandable. These are the functions that are applied in order to get P, Q, R. Now, final output will be, if I write for the final output, it is a XOR gate. Look over here, and this XOR gate takes one input as C and the other input is R. So if I write it is C XOR R, so it will not be wrong. So this is what you have to do actually. You will be filling this P, Q, R and X according to the functions that are applied on it. So starting with the first one, that is P column. Column P is calculated by doing A and B. A and B means that you have to see the value of A and then B and then make it AND. So in the first column, the value of A and B is 0, 0. And remember that for AND, we have to multiply the values. So I'm just writing down a multiplication operation over here. So I can easily calculate P. 0 into 0 is 0. You have to consider the same column for calculating P. The first column, values of A and B are 0, 0. When 0 is multiplied with 0, you will get 0 as a result in P. Then the next values are also 0, 0. Remember, you have to consider the values of A and B only. Why? Because P is basically a function of A and B. So we will be multiplying A and B only in the corresponding columns. For column 2, values are 0, 0. Again, the result will be 0. 0 multiplied by 0, 0. The next column, A and B, is 0 and 1. So multiply 0 and 1, we will get 0. Next we have again 0 and 1 in the fourth column. 0 into 1 is 0. Write down 0 in P again. Okay. Next we have 1 for A and 0 for B. So 1 into 0 is 0. Then in the next column, look at the values 1 and 0. 1 multiplied by 0 is 0 again. Okay, next in the 7th and 8th column, look at the values. You have both the values 1, 1 for AB. So 1 into 1 is 1. And for the last column also 1 into 1 is 1. So these are the values for P that we have written. Now quickly moving towards the values of Q. Okay, so for Q, what you have to do, you have to consider the values of B and C. And since there is a NOR operation between them, so remember that a NOR operation is the reverse of or we can say it's the reverse of addition. First, you will add the bits and then what will be the result? You have to reverse that bit. If it is 0, make it 1. If it is 1, make it 0. So, let me quickly do it for you. Now, consider the values of B and C. So, for column number 1, both the values are 0, 0. When you are going to add them, 0 plus 0 is 0. But what you have to do, the reverse of addition will be, since the result is 0, you have to make it 1 for Q. Because Q is not OR. The function of Q is NOR. And NOR is the reverse of OR. So the result is 0. For the addition it is 0. But we will make it 1 since it is a NOR gate. Then see the values of second column. 0 plus 1 is 1. But since it's a NOR gate, so we will make it 0, reverse of addition. Then 1 plus 0 is 1, make it 0 for NOR gate. Then 1 plus 1 is also 1, but make it 0 since it's a NOR gate. Okay, 0 plus 0 is 0. We will make it 1. Then 0 plus 1 is 1. We will make it 0. Then 1 plus 0 is 1. Make it 0. You have to do it very carefully. Then 1 plus 1 is 1. We will make it 0. Reverse of addition. So just quickly see that 0, 1, 1, 1 becomes 1, 0, 0, 0. Similarly, 0, 1, 1, 1 becomes 1, 0, 0, 0. We have reversed all the bits once we have calculated the addition of B and C. So Q is also done. Now quickly see the intermediate value for R. So the function of R is basically P or Q. It is the simple addition of P and Q. So to calculate R, you will be considering the values of P and Q only. So for the first column, the values of P is 0 and Q is 1. 0 plus 1 is 1. Put it in R because R is an OR function and it is simply the addition. You will not reverse it because this is not NOR, this is OR. Second, 0 plus 0 is 0, 0 plus 0, 0, 0 plus 0, 0, 0 plus 1, 1, 0 plus 0, 0, 1 plus 0 is 1, 1 plus 0 is 1. Here we go. We have calculated R by simply adding P and Q. Next, the last one is your final output. So in the final output, what you have to do, it's a XOR gate. So XOR gate means that first of all, you have to consider the values of C and R. So let me highlight over here. This is C and this is R. Both the values is going to be XOR. Remember that a XOR gate is the one in which you will have one input output only when you have dissimilar values. Dissimilar input means that if the inputs are 0, 1 or 1, 0, then you will have one output. And if you have similar values, this is the function of the XOR gate. 0 output will only be written when both the input values are similar. Similar means that if both the values are 1, 1 or 0, 0. So let's quickly do that. See the values of C and R. I'm just highlighting over here. This is C and this is R. So for the first column, you have dissimilar values 0 and 1. So the output will be, it's the easiest way of doing XOR, that when the values are dissimilar, the output will be 1. Again, you have 1, 0. So the output is 1. So write down 1 in the second column due to dissimilar inputs. Now look at the third one, 0, 0. 0, 0 means that you will be having same values means now the output will be 0. So this is as simple as you understand. XOR gate is only when dissimilar inputs, write 1. When similar inputs, write 0. So next is 1, 0. 1, 0 dissimilar, write 1. The next is 0, 1. Dissimilar, write down 1. Next, 1, 0. Dissimilar, write down 1. Then 0, 1. Dissimilar, write down 1. Then finally 1, 1. 1, 1 is similar, so write down 0. So this is how you are going to do this problem in filling the truth table. X is your final output. Okay, I hope that this problem is clear to you. In the next video, we are coming with another example. Stay tuned, stay connected, and do not forget to subscribe the channel. Bye bye.